Let's zoom into our next thought leader, who comes with 23 plus years of extensive experience in the financial services industry. Equipped with deep-rooted expertise in SRE, DevOps, product delivery, automation, and application modernization, our DevOps stalwart is a site reliability leader currently serving in his role as a co-founder and CTO at Watermelon Software at Singapore. In today's talk, he'll be joining us to share his deep insights and takes on his belief that reliability is for everyone and how organizations can chalk out a roadmap to embark on a sustainable reliability journey with DevOps. So with that, I'm very pleased to invite on stage the co-founder and CTO at Watermelon Software Inc. Please put your hands together for the one and only Mr. Harpreet Singh.
Hello and good afternoon, everybody. Kind of delighted to be here today. I hope a lot of you are not sleepy after a good lunch. Let me know if you need to do a bit of exercises before we kick on. I know there are a lot of people online as well, so without further ado, I'll kind of get started. So topic for today is reliability demystified. Reliability means different things to different people, and to each its own. Right? A lot of people talk about, site reliability engineering, and the constructs could vary from organization to organization, right? However, I'll try to demystify that a bit today, and hopefully, you could resonate with what I'll be sharing. All right. What do you see on the screen? You actually see a broken car, right? The car is available, but is it actually reliable? This is a fundamental question to ask, and a lot of people, a lot of organizations for that matter, still believe that being available actually means being reliable. Now, yes, availability is absolutely essential. You've got to have your systems available, but is availability really only reliability? So let's dive into a couple of examples, right? How many of you were disappointed that you did not land a ticket for the Taylor Swift show? Right? My daughter was annoyed, and she still is to this day, right? The websites were all available, but you just couldn't book the tickets, right? What does that actually mean? It doesn't mean much, right? Imagine you as a mobile banking user. You've logged into your application, you want to do a funds transfer, you want to make an urgent payment, but you actually can't make that payment. So how good is that availability? So organizations need to break that mindset of thinking that being available actually means being reliable. Now this requires a paradigm shift, because a lot of businesses, you can relate with your own organizations, still measure their reliability goals based on downtime, complete downtime. So they could tell you that, hey, I approve 4 hours of unplanned downtime this year, and that's good enough for you to meet. But what about the millions of requests that actually failed? What about millions of conversions that didn't happen, right? So all those actually contribute to reliability, right? So you've got to look at a few things, and probably we'll distill that down to a couple of things, and I'll kind of share that as we go through, right? So all these websites, right? Probably the Taylor Swift one is good enough for me to talk about. But one of the things that you also need to be mindful of is that there's no silver bullet, right? You could do a lot of things and you could still have problems. Even the best of the best actually have problems, right? But the ability to deal with those quickly, the ability to bounce back and still deliver a good customer service is what you actually need to get to, right? And that, in very simple terms, is actually a reliable system. Now, leaving everything aside, reliability in very simple terms boils down to two things: high success rates and highly performant transactions. So probably I'll give you a slightly different perspective. Assuming you run an application that's serviced by 10 JVMs. Now all 10 JVMs could be up and running. Does that actually guarantee that your application is working as expected? On the other hand, you could actually have 5 JVMs that are down, but you could still achieve both of these, right? And that's where you need to engineer your systems and build for that reliability, right? There are lots of jargons where people say, build for availability, build for failure, and all of that. Yes, all that is valid. But fundamentally, it just boils down to these two things, right? High success rates and highly performing transactions, right? If you go back 10 years in time, right? If you had to fire a transaction, and if that transaction took 10 seconds, you'd probably tolerate it. In today's day and age, anything that takes more than a second or two, our tolerance levels are really low. We can't accept that, right? Because, we've got other things to browse and look at, right? So the customer demands are so high and the tolerance to failure is so low that systems need to be highly reliable. But if you could get to these two, I think you would have done a great job. Now, what hampers reliability, right? There are lots of inefficiencies that actually contribute to unreliable systems, and reliability remains elusive for most organizations. It's just that they haven't started looking at reliability through that lens, right? Now, what you're actually seeing here is just a standard SDLC, right? Your business has some requirements, they get written as user stories, someone's developing code, and you actually move forward. But what you realize, or what you don't realize rather, is that you build your systems with a lot of technical debt. And that technical debt starts to grow as you go through the entire SDLC. Now, at some point in time, you would actually realize that, hey, my architects wanted to build it in a certain way. My business requirements wanted me to deliver capabilities A, B, and C. But when you get to a kind of a stage where you're actually testing for an application, you actually realize that, this isn't the way it was meant to be. And at that point in time, you're left with two really bad choices to make. Choice one is to actually roll back and delay your release, which a business will never accept, right? Because they've invested time, they've invested money, and you've made a promise to take it into production. The second bad decision is to take it forward into production and deal with it there. And that is what happens 9 out of 10 times, right? And if you take it into production and deal with it there, trust me, you are struggling to keep the lights on. You just can't focus on reliability. Now, while we all learned from Google and they said great things about, managing reliability through, error budgets and, upskilling your ops people to become SRE and automate yourselves out of the job, all that is fantastic. But the point, what they did not cover was about the practices on the left, right? And we'll talk about that as we go through this. So with these two choices, you are always catching your own tail, right? You just will struggle to have reliable systems. Now, so how do we solve it, right? Well, a lot of the mantra for everything is shift left, right? Shift left and you can solve it. Yes, there are certain techniques and tricks and practices that you could imbibe into your flows that help you achieve that. So let's understand that from another industry, right? So what you're seeing on the screen is some statistics around the automotive industry. So interestingly, today if you buy a car, even say you don't buy a very expensive car, right? Even if you buy a normal car, which is probably a mid-range car, you still have a certain promise of reliability. You still would probably feel safe driving in it. Unlike in the 60s, when the automotive industry was actually growing at a very big scale, in the early 60s, if you look at the fatalities per 100 million miles, it was at 5.1. So the cars were actually a lot unsafer at that point in time. If you look at the statistic as of 2019, with 3.3 trillion miles clocked, the fatality rate is only 1.1. So that did not happen magically. The automotive industry learned this way ahead of time, and I think software is at a stage where we could learn from them. So what did they actually do? They started focusing on design elements. 2-point seat belts, 3-point seat belts, crash testing, all of it put together is where the automotive industry is today. And they are continuing to evolve, right? Cars are probably really, really safe today. And that's where we've got to take software industry, right? And imagine now when people talk about chaos engineering and all that is right. I would draw a parallel to crash testing, right? So there are enough learnings for us out there to kind of bring that into the software industry as well, right? Now, I'll probably spend quite a bit of time on this slide, right? I can talk about on this for an hour, but I'll try to keep it to about 10 minutes. Now, we all looked at the SDLC and we do understand what happens. But behind the scenes, someone's designing a system, someone's writing code, someone's testing that code, someone's validating that architecture and so on. And remember, we spoke about the technical debt that gets accumulated, right? Technical debt, yeah, people do measure it in terms of code quality and so on. But fundamentally, if you look at it, your technical debt sits everywhere. Talk about design. Your architects wanted to build it in a certain way, but what actually gets implemented could actually be very different, right? Because, you know, what was drawn on paper and what gets implemented is very different. So how do you actually validate for that? So if you don't validate your architecture early, you're going to have a problem later on. The problems don't stop there. The problems evolve even once you're into production. And I'll give you an example. Probably you could also think back at your own systems. You have a category 1 system that's servicing your customers. Over time, you could add business functionality that gets delivered from a lower category system, a Cat 3 system, for example. So you are only as strong as your weakest link. So what that means is if your Cat 3 system falls over, your Cat 1 is going to fall over as well, which means you're going to get a high severity incident. All these contribute to reliability issues. So you've got to watch it like a hawk and make sure that you don't fall in or don't get into these pitfalls and have those problems. And that's what we call as critical path analysis, right? At any point in time, do you know all the critical points within your design that can lead to negative customer experience and the goals that you need to achieve, right? And then, of course, techniques to deal with that, right? Chaos engineering, having the right observability. I know Manjunath in the morning, if you remember his slide, he said observability and start there, right? Because you've got to start measuring, you've got to understand your touch points and so on. So that becomes very, very important. But again, if you take it back in a very layman term, a fundamental question to ask is, should my design be resilient enough? The answer is yes. So do what it takes to have that kind of architecture implemented. The second thing is, okay, now you've solved the architecture problem. Now let's look at it from a code quality perspective. So maybe, you know, you could probably again reflect on how you guys do it today. But from a code quality perspective, what are a few things that you look at today? You're looking at code smells. So you run a sonar scan. You're looking at your code smells and you're dealing with that. You're looking at vulnerabilities. Maybe you run SAS scans, DAST scans, pen tests. You solve for that. You're looking at OSS, right? And all your open source libraries that you're using. So code quality, while all of this is essential, does it contribute to reliability? Your code will be reliable, or your customer experience through code would be reliable only if you build reliability features. Graceful degradations, having the right rate limiting concepts. The best example I always love to share is Netflix. And all of us are Netflix users, hopefully. So when you log into Netflix, the experience is so seamless that you don't realize it. So when you log in, you actually see, what's trending in your location, what are your top picks, my list, and so on. But have you ever noticed that the order is not always the same? Have you ever noticed that sometimes some of those are missing? Probably they've taken down a service for maintenance. Probably they are doing some experimental features, but to the end user, it's not visible to you, and you probably never noticed it, right? And that's the beauty. How did that come about? That came about with a great design and some fantastic coding. So can you bring this? Of course, if you put it in a banking context, you could say, oh, I can't gracefully degrade my service because a customer wants to do a fund transfer, but I can't ask him to buy a share of something. It doesn't work that way. But the point is, there are things that you could bring in. Maybe you're caching data from another system to supply rates. If your rate system is down, maybe you could supply rates that were 5 minutes old, but you're still giving some response back to a customer. Some customers may make do with it, some may not. But at least you're not going back and saying service not available and showing a downtime there, right? So there are things that you could bring in there as well. Testing, highly overlooked area, right? Testing over time is seen more as a cost center rather than a quality center. And what I mean by that is organizations are throwing people at testing thinking they'll solve the problem. Testing, to be honest, is a 3-decade problem. 3-decade-old problem, largely unsolved. Why is it unsolved? It's cumbersome. People can't automate fast enough. People can't maintain their test scripts. People can't run testing effectively through the pipelines. Big problem. A lot of testers, a lot of organizations are still relying on manual testing. How do you achieve velocity with manual testing? How can you test for scenarios? I'll give you an insurance example. Imagine if you had to buy an insurance policy. Imagine the permutations and combinations, right? Age group is a factor. Being a smoker is a factor. Somebody who's a drinker is a factor. Someone who has dependence is a factor. With so many permutations and combinations, how can you deliver a reliable system through manual testing? It is practically impossible. And what happens is testing, end of the day, becomes a tick in the box, and people just claim that they've done regression for major releases, and things fall over in production, right? And that does not promise reliability. So it's a big problem, right? So how do you solve for that? I know Manjunath again mentioned this morning about observability-driven development. How about observability-driven testing? If your developers and testers have early insights into customer experience at the testing phase, would they not deliver a better customer experience in production? What's happening today is you're hit with an issue in production, a problem ticket gets raised, a tactical fix is done, and then that's the end of it, right? Did you go and look at, hey, what was the waterfall analysis for that failing transaction in production? And then try to fix that, right? So it becomes extremely, extremely important to look at testing with the lens of reliability. Going forward, a tester saying a pass or a fail is actually not going to be good enough. So that's something to really think about. Talk about release management. You've got to push code into production, and I think Wesley spoke about doing canary deployments and all of that. Absolutely essential. How can you deploy code safely, right? Now, a lot of people would argue saying that, hey, I'm running 90% of my footprint on-premise, on VM-based infrastructure, and I can't do a canary deployment. It's too hard. No, it is possible. It's just that you've got to be a little crafty and innovative, and it's still doable, right? You could manipulate traffic at your load balancers and still route 1% of your traffic to one of your VMs. So you could actually do a canary even in a VM-based environment, on-premise, right? It's just that you need to put a little bit of thought and effort in getting there, right? So think about that. But one interesting thing when it comes from a reliability perspective, of course, you want to reduce change risks, but on the other hand, talk about error budgets, right? The textbook says balance between velocity and stability. Now, the textbook says it, and a lot of people talk about it, but are people really practicing it? Actually not. Today, maybe again you can reflect, when you approve a change request, what are the things that go into a change request? Your implementation plan, the system on which you're going to deploy, what's the change window that you're going to apply? Do you have a rollback plan? Was the UAT sign-off done? How many of you actually look at the services in production, whether they're doing well or not? If they're not doing well, would you want to push another feature and make it worse? Or not get the true outcomes that you want to get? Or focus on stability and then push your features, right? So using error budget, or the concept of error budget, right? People could practice it in different ways, but the point is it is powerful enough. It is simple, yet powerful, but the problem is organizations are not using it effectively, right? So that's a very important factor, because you've got to look at customer experience before you make changes. And that's the sixth dimension that needs to come into change management, right? Observability, right? It's a no-brainer. You've got to observe as much as possible. I like the terminology. I think it was FI as a vendor. They call it customer to code. So you've got to measure all the way from your customers to your code, right? And observability, again, a lot of organizations claim that, I've got monitoring, and monitoring is observability. It's a part of observability, right? And observability, you've got to start looking beyond production as well. And what I mean by that is, are you looking at your pipelines? Are you looking at skill gaps that your developers have? See, assuming you've got a service running in production and that's not doing well, you could potentially trace that back all the way to unskilled developers who are delivering that service. How do you get to that, right? So observability is a lot more than just looking at things on the right. You've got to start looking at things on the left. We talk about observability in testing. So you've got to think about how can you enable your testers and developers to have the right observability earlier on. So observability, the mindset has to shift, saying that it's not only on the right, but it's also on the left. And lastly, incident response, right? I think incident response, a lot of people talk about auto remediation and all that. But what I realize is a lot of the foundational elements are missing. How many of you, hand on heart, maintain an error glossary today? And what I mean by that is, do you know all your functional or technical errors and business errors? Are you able to bucket them separately? Do you know how you handle a technical error? And when that technical error happens, what is the business treatment for that failure? People don't do it. It's a big, big, big gap. How could you respond to incidents if you don't have that knowledge, right? So knowledge management becomes very essential. I think getting to auto remediation and all that is great, right? You've got to do that because problems will happen and you've got to bounce back really quick. But one of the things I've realized is auto remediation still happens at an infrastructure level. What I mean by that is, I've experienced that this JVM is down. I can quickly restart it automatically. Yeah, essentially, you've got to do that. You've got to bring that back into service, right? But there could be complexities. How do you deal with those complexities when it comes to auto remediation? So you've got to look at that, right? So a few takeaways here. Error glossaries, think about having the right knowledge, reduce your key person risks. And what I mean by that, probably again, you can reflect on this. If you look back at your own teams, there would be one or two champions who know everything. They can just look at a log and tell you where the problem is. Good luck when they're on leave or when they leave the organization. You are stuck really, really bad. And sorry to say, I know not a lot, but I've heard of people holding the organizations to a ransom because just that they know the systems well. And people have to live with that. And that's an undesirable situation. All of these lead to reliability problems, right? So I hope there's a bit of a recipe there for you to look at. Now, again, we talk about shift left and doing all of these right, but the fundamental is reliability cannot be an afterthought. It's got to be the primary thought and has got to be part of every single aspect of system delivery. And what we mean by this is, you've got an idea for a product. Great, you've got to think about use cases, features, and all of that, but you can't put reliability in the back burner, right? Imagine you've got the best features out there, but if you deliver an unreliable system to your customer, are they going to get bang for buck? Are they going to get the outcomes that you intended to give to them? You're not going to get that, right? And all of this can lead to, reputational risks, and so many other problems, right? Of course, you can replace the word reliability with security, and it's just as important, right? So hope that this is an interesting takeaway for you. I know Manjunath mentioned about this in the morning, digital immune system, right? So that's a top trending trend in 2023. And I think Manjunath covered this earlier. There are 6 elements, and I'm not going to talk about that for sake of avoiding repetition. But that's an important thing, right? So systems have to be digitally immune. And what does it take to get them to be digitally immune, right? So I know Gartner called out 6 items. I've got a slightly different take, but there's a huge overlap with what Gartner called out. Autonomous testing, right? We spoke about it. How do you bring the whole reliability aspect into testing? So observability is one part of it. Observability into testing, testers thinking beyond a pass or a fail, ability to bring in chaos experiments and run them against testing as well, against your functionality. Now that's the interesting thing, right? A lot of people say, I'm doing a lot of chaos, which is great. But what organizations are doing is they're still breaking a lot of stuff at the platform level. But are you preempting what your customer experience actually is when you actually inject a failure? They're all disjoint today. How do you actually bring those together to have those meaningful insights? It becomes extremely powerful, right? So autonomous testing coupled with chaos engineering actually solves a lot of that for you, right? Observability, again, no brainer. I think I've spoken enough about that. Continuous validation. Now this is important. The way I kind of interpret continuous validation is the right talks to the left and the left talks to the right, right? The left starts to preempt what's going to happen on the right, and the right provides a continuous feedback loop to the left. Now, I'll give you one example, right? So for organizations that have implemented error budgets, do your error budgets automatically engage your engineering teams? Do your error budgets go back to your engineering teams and ask them to prioritize certain services? Are they able to go and say that, hey, there are testing deficiencies? Can you solve for those, right? So the feedback from the right to left and the preemptive nature from left to right actually becomes very, very important. Auto remediation, again, I kind of covered that as well. I've added a couple more, which are probably not in the Gartner's 6 items. One is predictive capacity management. And what I mean by this is, are you able to preempt growth, right? Again, I think the Taylor Swift example is a classic one. They definitely would have anticipated millions of requests come through. But we saw a lot of capacity issues. They just couldn't handle the volumes, right? I was speaking to somebody in the US and the situation was the same there as well. So either people are not learning or are not planning well enough. Now, there's a very interesting lesson I learned from the folks in Google. I attended a workshop back in the US in 2018 with Google, and they basically put a problem statement and they asked us to draw an architecture. It was for replicating their logs across different geographical locations. So we quickly drew an architecture out. They looked at it, they said, okay, looks okay, do the sizing for it. And how do you size for a system, right? So we just, out of gut feel, put some numbers saying, this one requires 4 vCPU, 32 GB and whatever, right? Based on your knowledge and habit. And then they came and said, okay, whatever you've done. Can you show the math behind this? And there was no math. It was just gut feel, right? And they said, that's not the way to do it. The right way to do it is do it scientifically. And the problem today is capacity management isn't scientific enough, right? I've seen people plan or seen organizations or applications plan for growth by looking at 2 charts disjointedly. What I mean by that is they're looking at infrastructure volumes or infrastructure utilization in one chart, and they're looking at business volumes in another chart, and they're trying to do a correlation. To me, it's actually meaningless because one transaction could be 10 requests to your backend, right? So how do you correlate your factors or your rate could actually be very, very different when you look at these two in 2 different panes of glass. There are techniques to do it, right? You could use multivariate regressions to do it, right? So how do you bring these concepts in? How do you bring scientific approach into your engineering? And that becomes very important. And capacity planning is a great place to do that, right? And lastly, I spoke about knowledge management as well. Why is it important, right? A lot of people would say, oh, I've got Confluence, I've got documentation, and we do a lot of great stuff. Trust me, your knowledge goes stale one day after you put that together. Next day, your systems are different. Keeping your knowledge fresh is very, very essential. And it's a challenge, not easy, but it's essential, right? I'm pretty sure you could also relate to it. There was a situation, there was an outage, and my engineering lead was unavailable for whatever reasons. He was traveling. And I jumped onto the call, and I got in with my L1 support, and I asked the folks, hey, can you open up the documentation? Let's resolve it. The documentation was 1 year old. The machine was supposed to run Logstash, but when I logged in, it was running Kafka. So we were absolutely clueless as to how to solve the problem. Fortunately, my engineering lead called me back, and we resolved it, right? So those are situations you would want to avoid, right? For an enabling platform, it's okay. But for a market-leading system that generates revenue for you, you do not want to be in that situation, right? So I hope this demystifies reliability for you. And again, what's the enabler? Your pipelines are enablers. One of the important thing I'd also like to call out is the mindset, right? A lot of organizations say, oh, I'm not mature enough to embrace any of these. You will never be mature enough, right? You've got to start somewhere. So as we say, right, reliability is not a function of maturity, it is a function of mindset. You've got to start somewhere. The earlier you start, the better. Start small, start somewhere. Don't need to do all of these. Pick any one and get started. You will realize that you will start to grow, right? So it becomes very, very essential for you to beat that inertia and actually get started, right? The other thing, this is probably a message for all the senior management out there. provide psychological safety for your people, right? And what I mean by that is when you start, say, onboarding your applications to error budgets and all of that, your business might expect 99.9, but your systems were never built for that, right? Because now you're actually trying to retrofit a new concept into a system that was built 5 years ago. How could you achieve 99.9 on a system that didn't have the right investments? So, and a lot of people start to get defensive, saying that, I'm only at a 95% success rate and my management's not going to help me out, or they're going to not look at me in the right sense. So psychological safety is a huge driver for reliability as well, right? So if there's senior management out here, my sincere, humble request, please provide that safety to your people. Yeah, and I think you will actually see the dividends over time. I think with that, I shall end my talk. I hope this was useful. I'm reachable at LinkedIn. Feel free to connect with me. Always happy for an offline chat. And if anyone's interested to know what Watermelon is all about, would love to have a conversation, right? I did not want to make this a product pitch, but probably happy to talk about Watermelon and how we solve some of these problems for you. Thank you.